Nuclear fission releases several million times more energy than any chemical reaction could. Really heavy elements on the brink of stability, like uranium-235, get bombarded with neutrons. The neutron is absorbed, but the result is unstable. Most of the time, it immediately splits into fast-moving lighter elements, some additional free neutrons, and energy in the form of radiation. The radiation heats the surrounding water, while the neutrons repeat the process with other atoms, releasing more neutrons and radiation in a closely controlled chain reaction.
Nuclear energy: the good, the bad, and the ugly. The concerns over energy security are extremely important because of an ever-increasing world population. A lack of this amount of external energy, almost 7 billion people would be without basic necessities. Nuclear energy is currently the most viable energy source to mitigate global warming. However, the effects it can have on humans and the environment are devastating. To be specific, nuclear reactors leave nations open to radioactive leaks, terrorist attacks, and provide the opportunity for nuclear proliferation. However, with the advancements of technology, in the future these risks could decrease exponentially. This graph shows the types of energy used in the United States in 2014. As you can see, coal does take up the majority, but another big chunk of this energy is nuclear, taking up 19.5%. Getting rid of this energy source would leave 1/5 of the country without power, which would be absolutely devastating. Wind, wave, rain, sunlight, geothermal, and tidal energy are all energy producers, but they are variable in nature, dependent upon the sun and the wind. No wind, no sun, no energy. In addition to carbon dioxide emissions, coal has enormous pollution issues. Despite perceptions to the contrary, nuclear energy saves more lives than it destroys, and it ranks last in deaths per energy unit produced. Not only does nuclear energy keep the atmosphere cleaner, but less land is required to build nuclear plants. Furthermore, according to Conserve Energy Future, energy released by nuclear fission is approximately 10 million times greater than the amount of energy released by fossil fuel atoms. Since 1976, nuclear energy, which is less harmful than fossil fuels, has prevented 64 gigatons of hazardous carbon dioxide emissions from being produced into the atmosphere. Popular media sources have made nuclear energy feel more dangerous by printing memorable images of scorched fields and the horrors of radiation poisoning. But the statistical bottom line is that fossil fuels are the silent killers. Although the impact on the environment is far lower than other energy sources, providing electricity with no greenhouse effect or air pollutants may still feel threatened by nuclear energy. Dangers associated with nuclear energy can have adverse effects on humans and the environment. Reactors require large amounts of water for steam production and cooling. This can negatively affect fish and aquatic life. There is some environmental risk due to nuclear accidents. The full impact of which we may not fully know. In 1979, the 3 Mile Island nuclear plant in Pennsylvania almost experienced a disaster when one of the reactors experienced a cooling malfunction, which caused part of the core to melt. This near-fatal meltdown caused fear, stress, and confusion. The cleanup took almost 12 years and cost around $973 million. Fortunately, there were negligible effects on the environment and the physical health of the people living in the surrounding area. In 1986, the Chernobyl accident in Ukraine jeopardized Central Europe. On March 11th at 2:46 p.m., a magnitude 9 earthquake did tremendous damage to northern Japan. One of these places being Fukushima, home to a nuclear reactor. The earthquake and tsunami assisted in triggering the worst nuclear accident ever since Chernobyl. The power station that is located in the Pacific Ocean incurred major damage from the earthquake and tsunami. The piping in the building and the facilities for external power and backup power were annihilated. The next day, the leakage of radioactive materials was found in the front of the main gate of the power plant. The steam was filled in the building by the core meltdown caused by the dysfunction of the cooling system. This nuclear accident was originally rated 5, but then soon was raised to 7, the same level as Chernobyl. The Nuclear Non-Proliferation Treaty, NPT, was signed in 1968 and has significantly reduced the risk of proliferation of nuclear weapons among countries. The treaty states 5 countries as nuclear weapons states, and 3 others not part of the treaty as possessors of nuclear weapons. In an effort to decrease the discriminatory nature of the treaty, countries with nuclear weapons are required to help other nations in the peaceful applications of nuclear energy. Most importantly, the nuclear weapons states have come to an agreement to limit the role of nuclear weapons in global relations to work towards their elimination. The threat of nuclear terrorism is larger than it has ever been before. With rogue countries like North Korea possessing these weapons, we have never needed to be more careful. Once a terrorist group acquires nuclear weapons, preventing their detonation on U.S. soil would prove to be extremely difficult. These weapons could be dropped by aircraft or missile, or they might explode on board U.S. ships. As demonstrated by the leakage of illegal drugs into the United States, closing our boundaries to the entry of nuclear weapons is nearly impossible. In the future, the downsides of nuclear energy can and will significantly diminish if current technological advances continue. A lot of our current technology is outdated, but with new technologies, we might be able to overcome the problems of nuclear energy and waste, specifically diminishing the current danger. A company that's based in Georgia and South Carolina are building third-generation light water reactors that are significantly more efficient and a lot safer than older models. In addition to these futuristic light water reactors, thorium reactors are a significantly better source of energy. Thorium is a lot more abundant, it is easier to handle, and it is a lot more difficult to use in creating nuclear weapons. An additional advantage to thorium is that waste material might only be hazardous for a few hundred years, as opposed to several thousand years. The fissionable element of plutonium is another viable option. With additional research, advanced technology may ultimately prove to control atomic fusion, and the world would be able to provide practically unlimited clean energy at a lot lower costs. Finally, putting in new waste disposal systems might help sway some people that nuclear energy is worth another shot. In the interest of sustainable and safe energy development, we need additional research in order to solve the current problems and dangers associated with nuclear energy. Much of this danger can be countered by passing legislation for stricter laws and enforcing those laws both at home and abroad.